Tes, tes. Ladies and gentlemen, we are about to begin. May I kindly ask everyone to direct their attention to the stage, please? Please join us in observing the sanitary and safety induction. Following this, we will honor our nation with the national anthem of the Republic of Indonesia. While the national anthem plays, please stand up. Thank you. Watching this safety and sanitary induction, please sit down.
Selamat datang di Fakultas Kesehatan Masyarakat Universitas Indonesia. Sesuai dengan peraturan rektor tentang K3L yang berlaku di Universitas Indonesia, kami akan menyampaikan induksi keselamatan. Saat ini, kita sedang berada di ruang promosi doktor Fakultas Kesehatan Masyarakat Universitas Indonesia. Ruangan ini terletak pada lantai 1 Gedung G FKM UI. Ruangan ini memiliki satu pintu utama yang terletak pada belakang kanan Anda.
Terdapat dua potensi keadaan darurat yang mungkin terjadi, yaitu kebakaran dan gempa bumi. Jika terjadi kebakaran, harap tenang dan jangan panik. Karena ruangan ini dilengkapi dengan alat pemadam api ringan atau APAR yang terletak di samping lift Gedung G FKM UI. Segera informasikan titik api kepada petugas. Jika terlatih memadamkan api, segera padamkan menggunakan APAR. Segera lakukan evakuasi dengan mengikuti arahan petugas menuju titik berkumpul.
Jika terjadi gempa bumi, lakukan metode drop, cover, and hold on. Jatuhkan badan Anda, lindungi kepala Anda dengan tangan, dan berlindung di bawah kursi atau meja. Tetap bertahan hingga gempa mereda. Hindari area kaca dan benda yang menggantung. Segera lakukan evakuasi sesuai dengan arahan petugas menuju titik berkumpul yang berada pada area parkir Gedung G FKM UI.
Ya, jari langsung megangnya. Yuk, terus. Main. Yuk, ke sana.
Jika terjadi keadaan darurat, segera hubungi nomor darurat Fakultas Kesehatan Masyarakat Universitas Indonesia di nomor 021 787 2977 atau nomor darurat UI 14001. Fakultas Kesehatan Masyarakat Universitas Indonesia merupakan kawasan tanpa asap rokok.
Jagalah kebersihan dan buanglah sampah pada tempat yang telah disediakan.
Selamat menikmati acara ini dan tetap utamakan keselamatan dan kesehatan diri Anda. Karena budaya ketiga, budaya kita.
Ladies and gentlemen, please stand up for our national anthem of the Republic of Indonesia. You may take a seat, please. Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. May peace be upon you. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Selamat pagi and good morning esteemed guests, faculty, and students. It's my privilege to welcome you all to today's guest lecture on Transboundary Air Pollution and Overview. This event brings together distinguished experts to explore the complexities and challenges of air pollution that crosses national boundaries. Before we start, I would like to extend a warmest welcome to the honorable guest. The first one is Professor Bin Jalaluddin MBBS PhD from the University of New South Wales as our distinguished speaker. Our respected moderator, Professor Dr. Budi Haryanto, Dr. Al Ashari, SKM MKM, as Secretary of Public Health Faculty, and then Bu Laila, Bu Fitri, and also staff and our beloved participants. It is our pleasure to have you all here. I am Salwa Anfa, the Master of Ceremony who will accompany you this morning. Before we step into our first agenda, allow me to convey today's program. This event will start with the opening remarks from Dr. Al Ashari as Secretary of Public Health Faculty, continued with brief introduction of moderator by Master of Ceremony, continued with introduction of our speaker of the day by moderator, followed by presentation from our speaker and Q&A session. Last but not least, we will close the agenda with photo session. Now let's start with the first agenda of today's program. I would like to invite Dr. Al Ashari as Secretary of Environmental Health Public Health Faculty. Ladies and gentlemen, please welcome Dr. Al Ashari.
Ya, terima kasih. Thank you very much for the MC. Thank you very much for all of you and our very distinguished speakers today. Prof. Bin Jalaluddin, thank you very much to join with us today to deliver the. I think it's not only important but urgent for us, including for environmental health and public health course, which is the topics about transboundary air pollutions. Yeah. Okay. Today I will representing the Dean of Faculty of Public Health, not as Secretary of Public Health. I'm representing the Dean and the Head of Departments of Environmental Health, which is their best regards to Prof. Jal. Thank you very much for coming to us, to the Faculty of Public Health. I have to read it because this is official as the opening speech for the Dean. Very good morning. Assalamualaikum warahmatullahi wabarakatuh. Dear professors, college and students, thank you very much for participating today in our general lectures. On this occasion, we are honored to have Prof. Jalaluddin giving a guest lecture on a topic of transboundary air pollutions. An overview. Prof. Bin Jalaluddin, MBBS, PhD, is a co-joint professor at the School of Population Health, University of New South Wales, Australia. Allow me to welcome and thank you very much to Professor Jalaluddin. This lecture, given by Prof. Jalaluddin and moderated by our senior professors, Professor Dr. Budi Haryanto, is primarily presented for, but not limited to, the students from the Environmental Health undergraduate study program. The topic is very relevant to the current conditions, especially in Indonesia, as we might have observed, the health impacts of air pollution are continuously increasing. The health-related costs of the impact is indeed a serious concern for the government. Transboundary air pollution creating a regional and global health-related problems needs to be understood, comprehensively from many perspectives for adequate air pollution controls. Without further ado, let's start. Let us start to learn and enjoy the insightful lecture from Jalaluddin. Again, thank you very much. Best regards, the Dean of Faculty of Public Health, Professor Dr. Mondasri Korip Sudaryo. Thank you very much. Okay, thank you.
Thank you, Dr. Al-Ashari, for the opening remarks. Following the opening remarks, I am pleased to introduce Professor Dr. Budi Haryanto, who will guide today's enlightening discussion. Ladies and gentlemen, Professor Budi Haryanto is a professor of environmental health at Faculty of Public Health Universitas Indonesia and Director of Research Center for Climate Change Universitas Indonesia. He is Board of Directors of the Pacific Basin Consortium on Environment and Health from 2008 until present, Advisory Group for APRU Global Health from 2020 until present, and Fellow at Collegium Ramazzini from 2020 until present. Also committee member for International Society for Environmental Epidemiology from 2020 until present, and fellow at Collegium Ramazzini from 2020 until present. He got degrees on environmental health and epidemiology from Universitas Indonesia and UC Los Angeles respectively. His publication of more than 70 papers on environmental epidemiology and climate change health impacts included 12 book chapters as an editor Air Pollution's book. He was also actively involved in scientific climate talks at UNFCCC IPCC's COP15 Copenhagen 2009, COP21 Paris 2015, COP22 Marrakech 2016, and East West Center Honolulu 2022. He is very well experienced and expert, isn't he? Ladies and gentlemen. Okay, well, without any further ado, please welcome Professor Dr. Budi Haryanto to take over. Thank you.
Oke, thank you for namanya apa ya? Master Ceremony ya, MC. Oke, very welcome to you all. We already know to each other. Hopefully, ya kan? Ya, awas kalau nggak tahu ya. Oke, welcome to not only for the student but also from our colleagues who are interested in this topics, yeah. And of course, we are very honored, very much thank you to the coming of Professor Bin Jalaluddin. We call it Professor Jal. Okay, it will be easier for us because Prof Jal is also understand very well about the bahasa. Prof Jal originally from Malaysia with about 54 years already staying at in Australia. Yeah, so he knows well about the bahasa Indonesia. So if you have a question, you may use your bahasa or you may use English as well. Okay, I'd like to invite Prof. Jal to go to the stage. Okay, let me introduce Prof. Jal to you all. Wait, I have to open like a millennial person habit, yeah, opening the mobile to read something. Wait, I have to try to find it out. Where is it? Oh, yeah, you got over there. Thank you. Soalnya nggak gitu canggih ya pakai HP. Jadi dibantuin. Terima kasih. Oke, Professor Jal actually a senior public health physician and epidemiologist, and also conjoined professor School of Population Health and at the University of New South Wales. But Professor Jal also lecturer in the University of Sydney, and he spent his first 10 years of his professional life in hospital-based clinical pediatrician in Sydney, Perth, and the United Kingdom. For over the past 30 years, he has been working as an epidemiologist in the public health system in research, evaluation, and surveillance. And he is an invited member of the WHO Southeast Asia Regional Expert Group on environmental determinants of health and climate change. He is an investigator in the Center for Safe Air. It is actually an NIH MRC, Center for Research Excellence, and the Healthy Environment and Life. We call it HEAL Network. And very fortunate as also that I've been invited to be the what call it, honorary visiting scholar for 1 year this year, since March to February, March 2024 to 2025 at the University of Canberra. So we will have more time to see to each other, Prof. Jal. And that is also under HEAL Research Center. And Professor Jal is also experienced in quantitative research methods, program evaluation, and biostatistics. So we can see that very complete experience uh, of the Professor Jal reputations. And as we know as well that Prof. Jal right now, the academic reputation of Prof. Jal, Scopus H index is about 51, yeah, Prof. Jal. 51, your Scopus H index. Very high. Where if we compare to the University of Indonesia, the highest Scopus H index in the University of Indonesia is still under 30. And now we have the reputation academic of Professor Jal about 51, very, very high. Okay, we are happy to have Professor Jal, and now your time, Professor Jal, to share us your knowledge. Thank you.
Thank you very much. If I could have the first slide. I'm going to talk about transboundary air pollution, and let me just work out how to move the slides. So in this talk, I'm going to firstly talk about ambient air pollution, which is outdoor air pollution. And then I will highlight some of the issues around transboundary air pollution, give some examples about transboundary air pollution, and then finally talk about the regional and global responses towards transboundary air pollution. So firstly, just to talk briefly about outdoor air pollution, it's a complex mixture. When we talk about outdoor air pollution, it's air pollution is made up of gases and made up of particles, and they're fairly complex particles. There are different sizes particles. The sources of the particles can be different. They can be from traffic exhaust, can be from combustion, from forest fires, bushfires, from dust storms, and so on. So the um, um, the, the the particle composition. Just a second. Let me try to work out holding both these two things. So in terms of the common air pollutants, we have ozone, we have particulate matter, which are the fine particles, nitrogen dioxide, sulfur dioxide, carbon monoxide, and lead. And so these are the common ones that are measured fairly regularly through the government monitoring systems. And then we also have um, um, other kinds of gases called air toxics, which are things like benzene, xylenes, toluenes, which are also all part of the air pollution mixture. But we often tend to focus on the particles. So when we talk about air pollution, we often focus on particles, mainly because our knowledge of the health effects of air pollution, we have the most knowledge around the effects of fine particles. So we tend to focus on that. But the air pollution, as I said, is a very complex mixture, and the particles of many different sizes, and that's important because the size of the particles is important. The large particles, when we breathe in, it gets trapped in the upper airways, in your nose, on your back of your throat, and those big particles don't get into your lungs. And we don't think those big particles then have health effects. Whereas the fine particles, the particles less than 10 microns in size or less than 2.5 microns, the small particles get into your lungs and to your small airways, and they're the ones that we think are mainly causing the health problems. And I've spoken about this, is the fine particles that get deep into your airways. And also the very fine particles can cross into the into the bloodstream. And then once it gets into the bloodstream, it can travel to all parts of the body and all our organs. And so it can lead to problems in many different parts of the human body systems. So here's an example of a sort of diesel particle, and so in the center, the nucleus of the particle is a sort of carbon, and then around that you may have organic compounds. You may have heavy metals on it, and so different particles will have different. Particles that come from different sources will have different composition. And what we're not quite sure is whether all the different kinds of particles have the same effect, have the same kind of health effects. So therefore, a diesel exhaust from cars, will they have the same effect as from smoke particles, for example? So smoke particles that come from forest fires, will they have the same effect? We're not quite sure. We think we don't have enough evidence, enough research evidence to be absolutely sure. But we think that the PM 2.5 or the fine particles that come from coal combustion and other things may have a greater effect. I might have to stand up now. I can't read the screen. The air pollution is fairly common throughout the world. And in some parts of the world, it has been increasing. And in other parts of the world, air pollution has been improving. So this graph here, this figure, shows air pollution levels from, I think, 1990 then to 2015. That's on the left-hand side, those two figures. And the figures where it's shaded red are the high air pollution areas. And where it's green, it's low air pollution. And you can see, looking at from 1990 to 2015, there are some areas that have become, there's more red in some parts of the world. And that's mainly in the Middle East, in Asia, where air pollution has increased. And if you look at the figure on the right-hand side, that shows the difference between 2015 and 1990. These are the areas where air pollution has increased. So again, it's mainly around Africa, Middle East, and Asia. And we also, air pollution is a concern because we think there's no safe levels of air pollution, of outdoor air pollution, or fine particle air pollution. The air quality standards, most countries have got air quality standards, and they usually set at maybe, let's say, 10 micrograms per meter cube as an annual average, or 15 or 20. So this may make you think that below the air quality standards, for whatever they are, for whichever country, that you'll be safe below those levels. But more recent research has shown that this is mainly research from North America and from Europe, has shown that even in those countries with low levels of air pollution, they're still finding health effects. There's still health effects from low levels. So now our thinking is that there's no safe level of air pollution. So even at very low levels, so here are, in terms of the health effects of outdoor air pollution, and here we're mainly talking about the fine particles, which are the fine particles less than 2.5 microns in size. So they're so fine that you can't see them. You can't see it. They're very, very small. And air pollution, in terms of the disease burden, is the fourth largest risk factor. So the greatest risk factor to health is high blood pressure, which is the first bar there. And air pollution is the fourth largest risk factor for health. So in terms of globally, it's a big risk factor. And if you look at the bottom of that slide, air pollution leads to about 40% of all COPD, or which is lung disease. 20% of all diabetes is due to air pollution. And ischemic heart disease, are things like heart attacks, infarcts, and it's about, again, 20% of all ischemic heart disease are due to air pollution. And about 19% of all lung cancer due to air pollution. So air pollution is a major cause for some of the common chronic diseases. These are things like heart disease, lung disease, diabetes. And now, if looking at the rates of deaths due to air pollution, Now, these are the trends in PM 2.5 deaths from from the year 2000 to 2019 by kind of various continents. And if or the figure on the left is just a total number of deaths. And you can see that the total deaths have been going up from the year 2000 to 2019. And most of the deaths have been increasing are in Asia. And if you look at the next one, that's a percentage of deaths due to fine particles. And again, in Asia, the number of deaths are much higher. And then the final graph there is the rate of death. And in some of the continents, the rate of the deaths due to air pollution has remained fairly constant. In Asia, again, it has been fairly constant, but the rates are much higher. And the health effects of air pollution are not confined to older people. So when we talk about infarction, diabetes, lung cancer, we think of older people, but it also has effects during pregnancy and on the newborn. So in newborns, there's a higher risk of low birth weight and premature babies, preterm babies. The effects on children, which and this is very important. The effects on children's lung growth, on their intellectual development, and more asthma and more wheezing in children. And there are also effects on adults and in older people. So the effects of air pollution is right through the age groups, from the very young to the very old. And it is really important in children, because we know that in children who have, for example, lung disease in early childhood, they will continue to have lung disease right through to adulthood and when they're older. And so what happens in the early childhood period is very important for the future development. So if we can prevent the effects of air pollution in newborns and children, then they'll have a much healthier life in the future. Now here's just looking at the cost of the health damage due to air pollution. And this is by various regions of the world and as a proportion of the GDP, or the gross domestic product. So in the first bar there is in South Asia, which is India, Pakistan, Bangladesh, Nepal, Sri Lanka. And about nearly 9% of the GDP is the damage due to air pollution, the health damage due to health pollution is, if you count in dollar values, is about 9% of the GDP. So which is very, very big. And the next one is East Asia and the Pacific, which will include Indonesia, Malaysia, most of Asia. Again, it's about 9% of the GDP. So air pollution, the dollar cost of air pollution and the damage to health in some parts of the world, it can be very high. And the other important thing also to realize is that some of the effects of air pollution can be reversed, or if you remove the air pollution, any damage to the lung function or to the lungs will improve. So this is from a US study where they recruited children and followed children up for about, I think, 10 or 15 years. And when children lived in high air pollution areas, they had damage to the lungs. And then in their 10, 15-year follow-up, some families had moved out of the high pollution areas to low air pollution areas. And when they measured the lung function again in this group of children who had moved to low pollution areas, they found that the lung function had improved. So I think I think there's some evidence now that in children anyway, the damage to the lungs can be reversed if you remove them from the air pollution. And that's important because the reduced lung function in children or lung damage in childhood is a strong predictor of long-term lung disease and longer-term heart disease. And this graph here just shows this graph is from the US, and I guess what we always think about is that in many countries, because we want to have economic development, as part of the economic development, the air quality suffers. And so that the thinking always has been that the poorer air quality is the price that we have to pay. You know, if we want to increase the standard of living, we need more industry, we need to produce more, and therefore the air quality will suffer. But in US, and again the same thing in Europe and in Australia, and these are obviously in high income countries. And in these countries, you can see that over the years, the GDP has increased. Can't do it, but the GDP has increased. The number of cars have increased, and the population growth over the years. So all these things have increased, but the air pollution has been, which is the line right at the bottom, the purple line, but air pollution has been decreasing over the years. So I guess what I'm trying to say is that we can still control air pollution, and we can still have economic growth. We can still use energy, we can still produce energy, we can have economic growth, but we can also control air pollution. So those two things don't economic growth and air pollution don't have to go together. So we can decrease. But this is obviously in a high income country. So it may not apply to low income countries like Malaysia or low middle income countries like Indonesia, Malaysia, but this is something that we can aim towards. Okay, for now, I guess what I've spoken about is more generally about outdoor air pollution, just to give you some idea of the kind of health problems it can cause and what the cost might be. And now I'm going to talk about transboundary air pollution. And the important thing about transboundary air pollution is that it kind of just happens. It happens because air pollution, outdoor air pollution, just gets blown around. So depending on in which direction the wind is blowing, the air pollution will be blown in that direction. And we generally don't have much control over it. So just a brief history about transboundary air pollution. In the 1800s, so now this is over 200 years ago, Robert Smith in England used the term acid rain. And then in the 1950s and the 1960s, there was in Northern Europe, in Sweden, Norway, in those countries, they was seeing that the the forests were dying and the lakes were dying. The water quality in the lakes was very bad, so the lakes were dying, the forests were dying, and it was because of acid rain. And in the late 1960s, Sven Oden in Sweden linked the acidification of lakes, of the waters in the lakes, and the rainfall to sulfur emissions in Europe. So these are sulfur dioxide from factories in Europe, and mainly in Eastern Europe, it was getting blown over to Northern Europe and to UK. And when it rained, the water, rainwater reacted with sulfur dioxide to form sulfuric acid. And the sulfuric acid then rained into the lakes and to the forest and killed the trees and I suppose you could say killed the lakes because it was acid. And in 1977, an OECD project concluded that the sulfur compounds travel long distances and that the air quality in one country in Europe can be affected by what is produced, the emissions that is produced from some other country. And in 1979, in Europe, they formed the Convention on Long-Range Transboundary Air Pollution. So the countries in Europe got together to say, okay, what we're going to do now, we know this is a problem. We are now going to do more research, and we're going to have some measures to try to control transboundary air pollution. So when we talk about transboundary air pollution, we can talk about long-range transport. These are intercontinental. So air pollution produced in Asia might travel to Europe. Air pollution produced in North America might travel to Asia, for example. We can talk about shorter distances, so within continents, and air pollution in India, because they're burning the crops, will then be blown over into Nepal, into Bangladesh, into Myanmar. It can be within countries. So this is not strictly transboundary air pollution, because within the country, there's no boundaries. But if you think about provinces, you may get air pollution from Jakarta Barat going to East Jakarta, getting blown over. So if you're living in a nice, clean environment, East Jakarta, East Java, and the air pollution comes from the western part of Java, you will not be very happy. So it is still an issue. It's not strictly transboundary, or it can be within cities. Within large cities, if you got areas where there are a lot of factories, a lot of industry, that may get blown over the rest of the city. So so we have to think about all this as kind of transboundary air pollution. And the sources of transboundary air pollution, again, there are things like landscape fires, which are forest fires, grass fires, peat fires, burning of after harvesting. You may burn the rice or the wheat stalks. Dust storms can get blown around. Industry, power stations, the emissions from industry, power stations, transport related like cars and shipping. And finally, there are other sources, for example, volcanoes. And we know, I think some years ago, there's a big volcanic eruption on the island of Bali, and the ashes did travel so long distances. And we must also not forget sort of plastics and microplastics. I think this is an emerging issue around environmental health and the plastics which can be both in the air and the oceans. And so I think there's another, this is an area which is now getting more and more interest around transboundary. So in terms of transboundary air pollution, that's obviously the health side, the health effects, there are economic effects. So, so for example, the Indonesian forest fires in 1977, I think there was some major, big fires in Sumatra, and they thought that it led to there's a large cost to it. There's a social problem, there's a social cost because of transboundary air pollution. So, for example, if you have large forest fires and the smoke gets then from one part of the country gets blown to other parts of the country, sometimes they have to close the schools, for example, or the businesses have to close. So there's a cost. Often the poorer countries are much more affected. So it's an equity issue. And overall, there's a big political issue also. So here, this is some old data from European countries, and it shows the percentage of air pollution that is transboundary, or the percentage of the total air pollution that has come from outside that country. And that ranges from about 30% to 60, 70%. So for each and every country in Europe, about 30 to 60% of the air pollution will be coming from its neighboring countries. So, so here's a fairly recent paper for East Asia, China, and showing transboundary air pollution from China in 2015. And in China, in this particular paper, there's estimated that transboundary air pollution accounted for about nearly 10% of all PM 2.5 deaths. And those various graphs just show that for each region of China, how much transboundary air pollution there is. And I'll just pick just one region. This is the southwestern region of China, and most of that air pollution comes from India. And so in the red areas, I think the amount of air pollution is about maybe 6 to 8 micrograms per meter cube. So it's quite a substantial amount of air pollution that comes from neighboring countries. So usually for transboundary air pollution, it will be the neighboring countries that the air pollution will come from. And this is here, again, looking at a paper from 2022, where they looked at where they did some modeling at a sort of global estimate. And so globally, they estimated that from 1950 to 2014, about 12 to 15% of all fine particle deaths, or PM 2.5 deaths, were due to transboundary air pollution. And in this particular paper, they looked at 4 different groups of countries. They looked at high-income countries, the low-income countries, and I think low middle income, and I think was probably medium upper income countries. And if you just look at the last dot point, the red one, in low income countries, about 60% of all PM 2.5 deaths were due to transboundary air pollution. So in these countries, the air pollution was mainly from outside that country, and caused about 62% of all the air pollution deaths. And now I'm just going to give some examples of transboundary air pollution. And the first one is about the forest fire smoke in Southeast Asia, and that is mainly from here. So this is smoke from the 1997 Indonesian forest fires, and it was estimated that it killed more than 100,000 people. And the fires were from Sumatra mainly, and the levels of air pollution was very, very high. So not only in Sumatra and Indonesia, but also in Malaysia, Singapore, the levels were, normally your levels of air pollution, PM 2.5, let's say, might be 50 micrograms per meter cube, but during the forest fires, they may be up to 1,000 micrograms per meter cube. And this is a paper from 2013 when they did some modeling of the 1997 forest fires. And the red area, the two graphs on the left and the two graphs on the right-hand side, the authors use different modeling techniques. So let's just look on the left-hand side. And so the forest fires were mainly in Sumatra, and I think some in Kalimantan, but the smoke went up to the Philippines. If you look at the yellow, up to the Philippines and to some parts of Southeast Asia. So depending on the wind direction and how strong the winds are, it will determine how far the smoke gets to. So, I mean, if it's no wind at all, then it won't travel. The smoke won't travel. But if it's depending on the monsoonal winds and the trade winds, it will get blown around. And the winds in that time of the year is mainly from the southwest. So it's going from southwest to northeast. So it gets blown in that direction. And again, in 2015, in Indonesia, there were some very severe forest fires again, some very bad forest fires. And in this particular paper, the authors estimated that in Indonesia, it led to about nearly 92,000 deaths. In Malaysia, about 6,500, and Singapore, just over 2,000 deaths. The next example is about dust storms in Northeast Asia. And in Northeast Asia, this is around China, Korea, Japan, Mongolia. The dust from the Gobi Desert gets in different seasons. It gets blown. You get dust storms, and the dust storms are blown. The dust is blown towards North Korea, South Korea, Japan, Taiwan, and so if you look at this map here, in Japan and South Korea, the dust levels can reach up to 500 micrograms per meter cube. So these are very high levels of dust, and it causes health effects. And this paper looked at Asian dust and deaths in 47 cities in Western Japan, and in some of the northern cities, they found an association between dust concentrations and deaths. And in this particular paper, they looked at dust levels in China and asthma in the US. And severe sandstorms in China was associated with small increase in acute respiratory disease hospitalizations in Western US. So obviously the dust travels from China to the US. The next example is about transboundary air pollution in South Asia and the Hindu Kush region. And in India, in certain times of the year after they harvest, I think that the rise of the wheat crops in the northern part of India, after harvesting, then they burn the residue, they burn what's left so that they can plant again for the next season. And the smoke from the burning of the crops will then get blown around from northern India to Nepal to Bangladesh and to Myanmar. So that's the picture there you can see is of the smoke haze. And in New Delhi, which is in northern India, this is from 5 years ago, this picture, the PM 2.5 levels were about 450 micrograms per meter cube, and you can see the haze. So we have very, very high levels. And in all those other countries too, there'll be high levels of smoke. And in the Tibetan plateau, these are now high up in the Himalayas, where you would think that it is fairly pristine. You know, up in the Himalayas, it is fairly pristine. But when we've measured air quality in those pristine, very clean regions, we found black carbon, which is mainly from India, China, Nepal, and the Middle East. And depending on the season and where you measure it, there'll also be black carbon is also from burning in Russia and from Africa. So black carbon particles from biomass burning can travel all the way from Africa and Russia to the Himalaya region. So what we see here is clean, looks great, very nice. But when we measure the air quality, they may not be high levels, but you can still find air pollution. And when they track it back, they can track it back from many other countries. And the final example is about coal-fired power plant emissions. So these are power plant stations that they make electricity using coal. So coal burning to make electricity in East and Southeast Asia. And this figure on the left-hand side shows the sulfur dioxide emissions from 2011 and what is projected to 2030. So if you look on the left-hand side, in Myanmar, Vietnam, and Indonesia, the blue is the sulfur dioxide emissions in 2011, and the red is what is expected in 2030, so using modeling techniques. And we can see that in Vietnam, in Myanmar, Indonesia, and maybe a bit in Thailand and Philippines, there'll be increase in sulfur dioxide emissions from coal-fired power stations. And if you're looking at premature deaths in Indonesia, which is the lowest, the bar at the bottom, the number of premature deaths due to fine particle pollution is estimated to increase quite a bit from 2011 to 2030, as well as in Vietnam and China, Myanmar, Thailand. So all of these countries, with the modeling they've done, they're saying that there'll be increased number of deaths from sulfur dioxide emissions. And then if you look at the figure, the graph on the right-hand side, This graph shows the deaths due to transboundary air pollution. So, for example, if you look at Indonesia, which is again the lowest, the bar at the bottom, most of the deaths will be due to air pollution produced in Indonesia. And only a very tiny bit, there's a little bit of green at the end. Only a small number of deaths will be from sulfur dioxide from outside the country. And I think that's from Malaysia. And if you can look at China, which is the third from the bottom, just about all the deaths from sulfur dioxide from coal-fired power stations will be because of sulfur dioxide from outside of China and mainly from Vietnam. So sulfur dioxide from Vietnam be blown over into China and then causing the deaths in China. And so, and also if you look, and I can't see the left-hand side of the graph, but you can see that for some countries, most of the deaths from sulfur dioxide pollution will be because of sulfur dioxide produced within the country. And for some other countries, many of the deaths will be because of transboundary sulfur dioxide. So the question is, what can we do about it? And now this is an issue that we don't have much control over. So for example, if you have a fire or you have industry, and if the wind is blowing in one direction, then it will be blown, the air pollution will be blown in that particular direction. So you may live in an area where there's no industry and it's pretty clean, but there may be certain times of the year or certain times of the day when you may be breathing in air pollution that is produced in some of the parts of the city or some of the part of the province or some of the country. So what's happened globally is that there's been very many different conventions or kind of agreements on how to control transboundary air pollution. So in 79, I've spoken about the Convention on Long-Range Transboundary Air Pollution in Europe, and in the ASEAN region, in our region here, there's the ASEAN Agreement on Transboundary Haze Pollution from 2002. Mainly because all the forest fires. So we now have the ASEAN Haze Agreement. Then there's in Northeast Asia, there's the Northeast Asian Sub-Regional Program for Environmental Protection. There's a Malé Declaration on Control and Prevention of Air Pollution. This is mainly in South Asia, the countries of South Asia. There's a North American Air Quality Agreement, and there are also many other smaller regional agreements in Africa, Western Asia, South America, and so on. So this is where countries that are affected have to come together and try to work out how we're going to control transboundary air pollution. So this figure here shows much the same thing. So you have the Malé Agreement in South Asia, the ASEAN Haze Agreement, which are all the ASEAN countries, and the Northeast Asia Clean Air Partnership in the East Asia region. And now, over the last few years, there's now the Forum for International Cooperation on Air Pollution. I think we have kind of worked out that the kind of regional agreements are good. So like the ASEAN Agreement and the Northeast Asia Agreement or the Malé Declaration, that they all are good things to have at the regional level. But really, to control transboundary, we need more of a global agreement. So this is, I think, the Forum for International Cooperation on Air Pollution. I think it's been only going for the last 4 years or so. And the purpose of the forum is to promote international collaboration towards preventing and reducing air, air pollution to improve air quality globally. So we've moved from regional partnerships now to a more global partnership. And I guess that there's also, what I've spoken mainly is about air pollution, transboundary air pollution, which is air pollution being blown over from one country to a different country, or one continent to another continent, and so on. And what this paper is talking about is we also need to consider, when we're talking about transboundary air pollution, is about the effects of international trade. And I think what this paper is trying to say is that China seems to be the sort of manufacturing capital of the world. And China then exports lots of goods to US, to Europe. In fact, so back in Australia, most things are made in China. If you're buying a pair of shoes or buying a shirt or trousers, they're all made in China. And probably be much the same here. It's all made, so China is the global manufacturing center. And what this paper is saying, that if China is the global manufacturing center and is producing large levels of air pollution, concentration of air pollution, then China should not be the only country bearing the cost of air pollution. And the countries that are importing Chinese goods should also be taking some responsibility of the air pollution, because you can't just, because the high income countries have exported their manufacturing to low income countries, not only China, but also to Malaysia, Bangladesh, Indonesia, Vietnam, and so on. So it's the low income countries that are now manufacturing for the high income countries. So there's an imbalance between the two. So one sort of proposal is that what is shown here is that on the top part, the high income countries have exported their high pollution industries to low income countries. And so what is proposed is that high income countries should be subsidizing or should be paying low income countries to try to reduce their air pollution. So it's an equity issue. So that now whether that will work or not, I'm not sure, but I think it's a good idea, so that the wealthy countries should be supporting the poorer countries are doing all the manufacturing or all the dirty manufacturing. And so they should be supporting that. So I think I will finish off here, and I will just leave this for you to think about. So thank you very much. And I'll be very happy to take any questions. But if it's a question in very difficult bahasa Indonesia, I'll let Tuan Budi to translate for me.
Okay, thank you very much, Prof. Jal. Uh, Distinguished guests, and also I noticed some of our colleagues is also attending this guest lecture online. Yeah, we have Prof. Haryoto, we have Prof. Vestal, we also have Dr. Luri and others. Yeah, thank you very much for joining us in online. And now, while giving Prof. Jal take a breath, I invite firstly for you attending offline, yeah, you're in this class. If you have a comment, if you have question, and please raise your hand. Okay, one, another. Okay, please give the mic for question. Please introduce yourself.
Yes. Okay, thank you so much for the opportunity. Hello, Professor Jal. My name is Irene. I'm currently in my third year in environmental health. Thank you so much for your presentation. It's very insightful. Now, as you've presented, we Indonesia, we have a lot of forest, and we also have a lot of forest fires, and we have a lot of history about that. There's a lot of issues concerning it. But as you have lived in Australia, right? So I want to ask about, I've heard that in Australia, to prevent forest fire, or I guess they say bushfires, they will deliberately burn off what could be the fuels of those fires. And so I just want to, maybe you can share with us how is it going in Australia, the application of those deliberate fires, and how does the Australia manage with the possible transboundary pollution, and is it really that effective, or do you think there should be another alternative to preventing forest fire in Australia, so that maybe we could also do it in Indonesia? So yeah, thank you.
Okay, thank you very much. It's a kind of good question. It's a big question. And in Australia, we have what you call back burning. So in usually around about April, May, they will burn off the what's called the fuel. So any dried wood, dried leaves that are on the floor, on the ground. So the plan is to burn off the fuel. So there's not enough fuel to have a large bushfire. So and that's what they call planned burns. So that they plan it, and then they will go and burn small areas at a time in different parts of the forest. There's still some debate about how effective these planned burns can be, and I think it's generally thought that yes, it is effective in preventing large bushfires. But in Australia, what we call bushfires, so they've been, I mean, we've had that for ever and ever, for a long, long time. So we all quite used to it. And Australia is a large country, small population. So most of the time, the bushfires don't affect, the smoke doesn't affect people, you know, because not many people live in those rural areas. So it's usually not a problem. But sometimes the planned burning so get out of control, or they burn and then it gets very windy and it gets blown around. And so that happens every now and then. But usually I think it works fairly well. Many years ago, they also used to burn, after harvesting sugarcane, they used to burn the the what was left. And after harvesting the rice, they used to burn the stalks. I think that's all stopped now. They've banned all that, so so that's not done. In terms of um, I guess in terms of big major forest fires, like we had one in 2019. In 2019, for about 3 months or so, we had some very, very severe forest fires, and the levels were very high, and the smoke plume, the smoke kind of traveled through New Zealand, through to west coast of South America, and then came back all the way to Perth. So it went right around the world. But those things is hard to control. So when it happened, we've never experienced such severe forest fires before. And so I think it was just whether it'll happen again is hard to know. In terms of the Indonesia, now I think the Sumatran forest, the Sumatran fires, they can be due to burning of the trees or the peat fires. And peat fires can be very difficult to stop because peat can be found underground, and the fires can burn for weeks and weeks or months and months and months. And often the reason for burning the forest are quite different. And I think because of, and I might be wrong here, but I thought it's mainly because they wanted to then grow sort of palm oil palms, and so on. And I think the conflict here, is that some of these companies they're either Singaporean companies or Malaysian companies who own the palm oil plantations. And so there's this conflict between the two countries. So it becomes a political issue then, because from my reading, and I might be wrong, is the Indonesian government then tells the Malaysian Singaporean government were telling the Indonesian government, you must do something because the smoke is coming over to us, and we had to close the schools down, and so on and so forth. And then the Indonesian government says, it's your companies that are doing it. So it's very tricky. And so I think that's why they have the ASEAN Haze Agreement, to bring the countries together to talk about how things can be made better. But it's always a political issue when you have smoke from one country, or industrial emissions, be it from industry, coal-fired power stations, from one country blown into some other country. The countries have to get together.
Okay, thank you. Yeah, very good question. Yeah, and then concerning the situation of bushfire in Australia, and also the forest fire, as well as a pit fire in Indonesia, that also related to we do not know yet whether they exported from Indonesia to Malaysia, Singapore, or Malaysia is also joining export to Indonesia for the air pollution among boundary of countries. And Prof. Jal is already giving the point of view from Australia. Of course, yeah. We have we are here in Indonesia is also struggling with the geopolitical issues concerning the transboundary haze. Yeah. So, well, yes, this is our challenging. All right. I invite another questions for those who attending online. If you also has question, please raise your hand. I think no other questions, Prof. Jal. So I would like to finish this uh, guest lecture. Ya, kita udahi saja ya, karena nggak ada pertanyaan lagi. Ada yang mau nanya lagi? Oh, we still have question. All right, over there. So it's not finished yet.
Oh,
Okay, thank you for the opportunity. Good afternoon, Professor Jal and Professor Budi. I am Sohaila Bilkisabdi. I would like to ask about efforts to improve air quality. So what are the challenges generally faced by stakeholders in a country, for example, Australia, um, in improving air quality there, and what are the solutions to face these challenges? I am curious to ask this because the health effects of air pollution are quite serious, and maybe the solutions implemented in Australia can be implemented in our country, Indonesia. Thank you.
So I think I think what you're asking, your question was what, how can we control air pollution? Is that correct? Okay, and I think in most of the countries, certainly in Europe and North America, was Australia, we've looked at the source. So firstly, you have to look at the source. What is the source of air pollution? What are the main sources? And we know that in most high income countries, it is often road traffic. Is one of the major sources of air pollution, and followed by industry is the second most common source. And in Australia also, in winter, people like to burn wood in the house to heat. I mean, they've got electricity heaters, there's gas heaters, but they also like to burn wood because it feels nice. So they have wood heaters. And the smoke from the chimney that goes up chimney and outside. And so that again is a major source. So we have to look at in each country or in each province or each area, you have to look at what are the main sources of air pollution, and then try to work out what are the solutions, like what are the best ways to control it. So for example, if it's traffic, and I suppose these days we are moving more towards so electric cars and so on, so we can reduce the emissions from using petrol and using diesel. And so that's one way. If we can reduce, or we're reducing car use generally, so we can have much better public transport, encourage people to catch buses and trains when they're going to work instead of driving. So we want to reduce driving. We want to get people to move to cleaner energy. And in some parts of the world, for example, when within the homes they're still using fossil fuels, using wood or charcoal to cook and to heat, then we want to move them from using those sources of energy to using electricity or to using gas. And if you're using electricity, then to use whether we can move to solar power. And so I think we have to look at in each area what are the sources of air pollution, and then and then find the solutions to those particular sources. Does that answer your question or help with your question?
Okay, very good question as well.
Sorry, Professor, we have one question from the Zoom. I will read it for you. Dear Professor bin Jalaluddin, thank you for insightful presentation. What methods are currently used by researchers to measure the impact of transboundary pollution on ecosystems? And what suggestions do you have for starting such research, particularly in Indonesia, where databases and access to air pollution or emission inventories are limited, difficult to access, or not available due to broken tools or lack of budgets? Thank you.
Okay, it's a difficult question to answer. I think just to say that in terms of measuring transboundary air pollution, I think I sort of don't do that. I'm more of a kind of health researcher, but it is the atmospheric scientist, the atmospheric scientist who tend to measure air pollution, and they have methods of kind of backtracking where the air pollution comes from. So that they can measure the air pollution in one country, and then they can look back and see, okay, where is the original source of the air pollution? And then they can say, look, maybe 30% of the PM 2.5 in this area where we're measuring it comes from these other countries. So I think that that's a very highly specialized science, and is the atmospheric scientist. I don't know whether you have atmospheric scientist here. Yeah. So they're the people who do all the measuring, the sort of monitoring, and then it's people like me who use that information. We use their information to do our health studies, and then look at the effects. The effects of, for example, PM 2.5, whether it's transboundary or whether it's locally produced, the effects will be the same. But that actual measurement is a very, very highly specialized science. I might just leave it at that, and I'm not sure whether there was a second part of the question, but
The second question is, what suggestions do you have for starting such research, particularly in Indonesia, where databases and access to air pollution or emission inventories are limited, difficult to access, and not available due to broken tools or lack of budget?
do you know answer this question? It's right. Look, it's hard. I think it's a difficult question for me to answer because I'm not a atmospheric scientist who has used emission inventories and so on. So I can't really answer that question. But I think if we want to do health studies around transboundary air pollution, then it is not just the health scientist who we need to involve, but we also need to involve the atmospheric scientist, because we need the experts to sort of measure the air pollution, whether it be transboundary component or the local component, and then we kind of need the epidemiologist the health researchers to use that information. So in Indonesia, if we want to have a program of research into the effects of transboundary air pollution, then I think we need to have a group of people with different expertise. So we need the air pollution scientists, we need the health researchers, and I'm sure there'll be a range of other people we need to involve to kind of develop a program of research. Anything to add, Budi?
Yeah, I'd like to add a bit actually. Uh, the study for identifying the transpondary pollution, this actually quite advanced here right now because this the very difficult work actually because as we know we are here or probably outside of this room we inhale everything. Yeah, we breathing and then inhale everything in the front of our nose. Yeah, and we have no choice to breathe it, as well as we do not know exactly what kind of mixture substance that we inhale at the time. And yes, we also do not know exactly whether this pollutant is came from surrounding of us, the sources of surrounding of us, or this is also from other sites, yeah, or probably other countries as well. Uh, but the modeling for identifying this the transboundary the contribution of transboundary pollutant actually available, yeah, and it had been uh, implemented uh, yeah around 10 years ago. It's been the name of this modeling is Gaines, yeah, at the time Gaines. Gaines is belong to the IASA, yeah, International Institute for uh, System Analysis, based in Austria, based on Australia, and the IASA you can browse it. IASA is actually the research center, the longest research center, multidisciplinary and involving almost all of the country experts. And the IASA is built is created uh, for the answer to avoid World War III. So after World War II, the countries what do you call it, insisted to build their war weapon, uh, but then almost all of country aware that we no need World War III. We no need to compete for the weapon, for the war plane, and so on. But now let's do together doing research for answering the problem of the world, something like that. So the IISA is very, very famous research center, and then providing as well uh, the modeling for identifying the transpondary of air pollutions. And however, if we are talking about, for example, Prof. Jal already mentioned about 30% of the concentration air pollutant in one site, probably the 35, 30 to 35% is contributing by transpondary pollutant sources of the pollutant. Uh, yeah, again, this is still in challenging research to identifying this. But okay, what we know about the impact of health? Yes, uh, we have the data about that, but we are only like okay, the number of asthma in the certain cases, and then the number of pneumonia, the number of lung function disorder, and other diseases related to air pollution. We have the data. It's already recorded by medical record, yeah. At the puskesmas, at the dinas kesehatan, at the, as well as from the medical record in hospital. We have all of the data, the diseases related to air pollution, but we don't know exactly whether these cases, these diseases caused by how much caused by transboundary pollutant or how much caused by local sources of the pollutant. So if we are talking about the health impact of the transboundary air pollutant, it's still in challenging in an under research. Yeah, there's very good to invite you all who are studying environmental health epidemiology. Yeah, to what do you call it? To join uh, thinking how to find out this very real in our life, yeah, because we do not know from where pollutants coming. Okay, I think okay. One more is about the limited of monitoring station. Yeah. Yes, Indonesia has this week of providing a monitoring station for air pollution. Yeah, because as we know that we are choosing, we choose the very complicated, not complicated actually, very high level monitoring system, yeah, monitoring station with high cost. So since the funding are limited, then we only have a few in every city. Like in Jakarta, we have only about 6, yeah, monitoring station because of very high cost. uh, as well as in Indonesia, we only have about 40 or 45 here in spread out in the 30 cities. So this very limited to show whether the air quality representative to every single city or not. So this the big question actually because of limited of monitoring stations. But right now, WHO as well, WHO and other international agency um, suggesting we may use the satellite data. So satellite data, it's mean that the air pollutant parameter, yeah, air pollutant concentration, and then and emission, we it's already been captured by uh, satellite, yeah, by satellite system. So like NASA has this almost all of the country. They may also reporting 6 times a day, 6 time concentration a day for every single parameter like PM 2.5, PM10, SO2, NOx, and so on. Like if you like to see what about the air pollution in Jakarta right now, you can access the NASA air quality. So uh, those who has satellite may be used for monitoring air quality in every single city by the satellite, and as well as if we know LAPAN ya, Lembaga Antariksa dan Penerbangan Nasional ya. Now the name is already been included in BRIN ya, Badan Riset dan Inovatif Nasional. LAPAN is also has the data, monitoring data by satellite. So do not to worry right now if you are we are insisting to see the air pollution among each city, then we can also use the satellite data. There is a real time, yeah, almost 6 times a day they reported the concentration. I think that is what I would like to add the answer from Sejal. Okay, one more question. We are approaching to 12 o'clock. No, any other questions? All right. Professor Jal arrive on Friday. Yeah, Friday night. Yeah, and then Saturday. I do not know. Where Professor Jal spending the time working. Yeah. Yeah. No. Okay, just enjoying it with his wife. And Sunday he visited. He also joined the walking in the car free day. Yeah, yeah. He joined walking in the car free day, enjoying there because from Jal staying at the Grand Hyatt Hotel. Yeah, yeah, hotel in front of Hotel Indonesia. And after enjoying car free day, Jal also walking to museum, yeah, National Museum, and then visiting Batavia Old Town. It's very good. And then yesterday, Projal having a good impression about uh, visiting Bandung by bus, by bus, and his impression actually too fast, too fast. Too short, yeah, only 23 minutes. That is good. And tomorrow, Prof. Jal will, today will be here, and then tomorrow, Prof. Jal will go to Yogyakarta for visiting Candi Prambanan, Prambanan Temple, and also Borobudur Temple. Well, please enjoying all of your time here in Indonesia, and I will. I wish you and your wife will be very happy visiting us here. Terus Professor Jal coming here is under the funding of our collaboration research, yeah, our international collaboration research funded by University of Indonesia. So I would like to thanks also to University of Indonesia that providing a PUTI grant for inviting Prof. Jar here, and we have a lot of uh, knowledge today about transboundary air pollution. Okay, there is no any other question. I'd like to again say thank you to all of the participants. Thank you online or offline. Thank you for our colleagues. Thank you for the committee. And I'd like to, oh, thank you very much to Professor Jalan, the star here. Okay, I'll give back to the MC.
Thank you, Professor Dr. Budi Haryanto, for leading a fascinating discussion. And also thank you to our distinguished speaker, Professor Bin Jalaluddin MBBS PhD, for sharing the enlightening knowledge with us today. Your expertise has enriched our understanding of transboundary air pollution and its global implications. I also want to say thank you to the participants who are actively engaged with the discussion. Now, as we come to the close of the session, let's take a picture to capture this special moment. For participants in the middle, you can stay at your place. For participants at the side, please gather to the center. And for professor, please, take a seat here. We would like to take a picture to commemorate this special event. For participants at the side, please gather at the center. You can just stand up. Okay, guys, three.
Mau gaya apa?
Gini katanya buka.